Good morning, students. We are going to perform the integrator circuits. As you can see, the integrator circuit is the circuit which we usually come across where capacitor is in the feedback of the amplifier. Okay. In the amplifier circuit, when the integrator has been designed, we usually known to the first principle that the voltage on the plate of the capacitor is always equal to the charge on the capacitor divided by the capacitance given by the Q times Q divided by C. Okay. Now, as a formula of the capacitor and the charge, you can see the output is actually the differential of the capacitor charge with respect to the time. And if we see the things here, you will find the current in a feedback circuit, that is across the capacitor, is IF, and the current in the resistor R is the input current IN, and the feedback current IF is equal to the change in the dq by dt, that is change in the capacitor charge per unit time, which is equal to minus of d out by dt, that is differential of output with respect to time into capacitor. And since we are continuously observing that the input current is same as the feedback current in the amplifier, therefore when we say that input current of the resistance R is same as the current of the across the capacitor C, then V in equal to IF, that means voltage by Ohm's law, V in divided by R in is equal to minus of V out divided by RT into C. Now if I rearrange the whole equation, we will get the output is equal to as the integration of the input voltage. Therefore this circuit is known as an integrator. So we will connect this circuit in the diagram as follows. You can see there are the components like CRO, dual power supply, signal generator, which varies the frequency across the resistor input resistance, and this is what we had a circuit. As you can see on the circuit, there is OPAMP and one resistor, one capacitor. This is what we call 741 OPAMP, and we will connect it on the breadboard. Now we are using breadboard for the easy references. Here we are going to, as you can see on the breadboard, we have connected OPAMP in such a way that 4 terminal of OPAMP will be below and 4 we will use above. From the pin number 2 to output, input, we will use the resistance, and pin number 2 to 6 we are going to use the capacitor. So we will connect pin number 3 as a ground. We will use the ground line, the horizontal line of the breadboard for the grounding purpose. This is what the capacitor, we are going to connect the capacitor between pin number 2 and pin number 6. Here you will see pin number 6 as 4 terminals we are using upward. So we will use this pin. We cannot, if we are not able to go up to that jumping, we can connect the capacitor on the other point, and then we will connect the wire to the pin number 6, or otherwise we will make the capacitor jump across the IC. Okay. Now we will connect a feedback resistance of 10 mega ohm across the capacitor in the parallel with the capacitor, so that our attenuation will be much more clear. Okay, this feedback resistor doesn't play any role. This is the dual power supply. We have three terminal on the dual power supply. Red and green will give positive 15 volt, green and black will give negative 15 volt, and that is can be adjusted through the dual power supply. Okay, the red terminal of the dual power supply will be connected to the pin number 7. The black one will connect it to the pin number 4. And the green one will connect it to the ground line which we used on the breadboard horizontal line. In such a way we are going to connect the circuit. Now we will just need to connect the input through the signal generator. This is the signal generator we are going to use to provide the signal, that is the AC signal, to the resistor R in. Okay, it has two terminal, black and red, and we can vary the signal generator. You can set the display and it is set on the into 10 raised to power, and we can change the frequency through the knob, gray knobs. You can see on the screen it's moving, and the amplitude also can be adjusted through the another knob given on the signal generator. Now we will connect black and red of the signal generator to the circuitry. The black is always goes to the ground, so we will connect this black terminal to the horizontal line where we are going connecting the every ground of the circuit, and the another remaining red terminal will connect it to the resistance input R. Yes, to the resistance R in. Yes, we have connected the resistor R in to the signal generator. Now we are going to connect the CRO to observe the output between the pin number 6 and ground, because pin number 6 is the output of the OPAMP, and this is the cord of the CRO which we are going to connect to the ground, black terminal as usual, to the ground of breadboard where we are connected the ground horizontal line, and then we will connect the red terminal of the CRO to the pin number 6 of the OPAMP to observe the output. We will set the frequency of 1 kHz. We will first minimize the whole voltage of dual power supply before running it, so that any mismatch or anything happens we will able to observe. Then we will make it full, that is 15 volt. Then we will turn on the CRO, set the time per division knob as a 1 millisecond, voltage as a 2 volt per division, and as you can observe the triangular waveforms on the screen, charging and discharging of the capacitor. This is the integrator output of this circuit. Now we have to measure the frequency of this signal. So we will take two consecutive crest or tuff of the signal to measure the difference between the two signals, and then multiplied by the time per division knob, and that will give you the frequency of the circuit. This is the differentiator. It's a similar circuit like an integrator works. Only the difference between the integrator and differentiator is the position of the capacitor and the resistance, which we have interchange in the differentiator. As you can see on the circuit diagram, that the capacitor has been placed in the place of the input resistance, whereas the resistance has been placed in the place of the capacitor, that is in the feedback of the dual OPAMP between pin number 2 and pin number 6. The circuit remains similar as an integrator, only there is the simplest difference is that we are placing capacitor in the input circuitry and the resistor in the feedback circuitry. This is the circuit which we have been doing for the integrator. We have replaced it for the differentiator. Capacitor has been placed at the input and given to the signal generator, and you can say change the sequence by changing the frequency. We can change the input frequency and the output. We are keeping input as at 1.2 kilohertz, and this is given to the capacitor, and the capacitor is connected between the input, that is CRO, and the pin number 2, and we have connected feedback. Here you will observe the output on the CRO, and you have to measure the similar way the consecutive crest or trough for observing the output.